Hello everyone, welcome back to another video. So today we will discuss editorial for weekly contest 394, and as you can see I solved all the four problems and I got a good rank, but it could have been better if I would have not made this silly mistake. So let's just start with editorial. So in first two questions I solved second one first because they are both of them it's easy for me, so I thought solving second, and I thought both questions are same but there are only constant difference or somewhat both questions are related, so solving harder one will be uh, faster. Then I can just submit that same solution for first one. I thought uh, something like that, so I jumped into second question first. So we'll discuss the second question. So in this question we are given a string word and a letter C is called special if it appears both in lowercase and uppercase in the word, and every occurrence of C appears before first uppercase occurrence of C. So let's consider character A. Now character A should is special if all the occurrences of lowercase a are before first occurrence of uppercase A. Let's say the uppercase A has first occurrence at I position. So all the indexes where there is a lowercase a, let's call it J. So J should always less than I. So that is a basic condition. Now if A is we have to find count of such characters. So A is 1, so similarly there can be B, C up to Z. So we have to find all the possible, all the special characters. Now in, for example, here there are three special characters A, B, C, because all the occurrences of A, lowercase a, occurs before this uppercase A, first occurrence of uppercase A. Similarly, all occurrence of lowercase b are before the first occurrence of uppercase B. Similarly for C. Now in this case, answer is 0 because there should be there should be both lowercase and uppercase character of a lowercase and uppercase form of a character in the string. So there is no uppercase A, B or C. So here answer is 0. And in this case also answer is 0 because for B there is an additional lowercase occurrence after first occurrence of uppercase B. Similarly, that's all. That's why B is not possible. For A again there is an lowercase a after first ever uppercase A, and for C there is no lowercase character. So how to do this? So this is a simple implementation problem. From A to Z we will store first occurrence of that uppercase letter. So for that what we can do is I have declared two maps. One is for storing frequency of string, and second is first occurrence of a character, and I have declared some extra variables. Now for I to n I will iterate over the string, and if this current character is uppercase, that is from A to Z, we if I have not mapped any character in the occurrence map, I will map it to I. So I will store the first ever frequency of first ever index of s of I, and mp just calculating the frequency. Now if there is an uppercase letter, then only there will be a mapping of that character in occurrence. So I am iterating in that map and finding the lowercase letter. So lowercase letter can be like found by incrementing the uppercase letter by 32, because ASCII difference between any lowercase character and uppercase character is 32. And if occurrence of that character, lowercase character, is 0, I will just continue. Else what I will do is I will iterate over string and check if there is any character which is occurring after the first occurrence of uh, that uppercase first character. And if there is, I will just make f equal to 0, break, and finally add increment answer according to this f. And if you see this for loop, this for loop will work, and the complexity of this for loop is 26 into n, so there is no time complexity issues also here. So this was first question. Then what I did here is I just copy pasted this submission here. I thought both are same question, just constraints are different. And then what I got a wrong answer because questions are different. So in this case, every lowercase letter should occur before the first uppercase occurrence, but in this case only a letter is called special if it occurs both in lowercase and uppercase in a word. So I don't need this extra for loop to check the all the occurrences are before the uppercase letter or not. So I copy pasted and then just uncommented this uh, code. And so what I'm doing is I'm just finding both the occurrences. So in this occurrence I have all the occurrences which of uppercase letter. Now I will check if there is a lowercase letter or not. If there is not, I will just continue, and if there is, I will go just declare int f equal to 1 and answer plus f. Now this can easily be done by just maintaining two maps, one for lowercase map L and let's say map U, and iterate over from A to Z. And you can construct character A from A like this, A minus 32, and using both the maps, if both the values in that map for a consecutive letter are positive, then increment the increment the counter. So this was second question. I think it was the first question, sorry, second and first question, and both of them were easy, just some implementation was required in second question. So let's just move on to third question. So in third question what we are given is a grid. So let's just read the problem first. So we are given a grid of size m into n, and in one operation you can change any cell to any non-negative number, and we need to perform some operations such that each cell in each cell in that grid is equal to cell below it but different from cell to its right. So if we have something, let's say I have a grid like this, what would be my ideal uh, what will be my ideal grid after making operation? It should look something like this. So x x x x, and if I'm putting here y should be different from x. Everything below it should also be y. Now I can either put x here or any other character except y, and that should be reflected over a whole column. So this is how a grid should look like. It should not be equal to its previous integer, and all the whole column should be filled with same integer. So let's see the first test case. Now in first test case, what we have is 2 into 3 grid and 102. Now in this case the grid is already uh, whatever already satisfies the given condition, because all the columns are equal and none of the adjacent cells are equal. Adjacent cells means the cell at right. So this and this. And in second case we are given again a 2 into 3 grid, which is like this: 1 1 1 0. Now here we require three operations. So what are those three operations? So I can just cut this 0 and make it 1. Now the conditions for first column are satisfied, but this one also matches its right side and this condition fails. So what I have to do, I have to make this one equal to 0. Now again for this column all conditions are satisfied and it is not equal to its, every element in that column is not equal to its left element. Now let's move on to third column. Now in third column this 0 fails the second condition. So what I can do is I can cut this 0 and make it 1. So I require three operations and the final grid looks like this: 101 and 101. So like this. There is also another approach where I do this 0 and this 1 and this 0, and all the other cells are as norm as uh, all other cells are same as initial state, and in that also I required only three operations. And this is the final case. This is just one column matrix in which first is 1 2 3. Now to make all of them equal I have to perform two operations: cut this 2 to 1, cut this 3 to 1. So there was two operations, and the constraints here are n into m is 10 raised to power what, 6, and but every element can be from 0 to 9. Now this was an important observation, important observation. So let's try to find some observations first. Now let's say I have two ones and all the other elements are different from 1. Now what is the number of operations required to make all the elements equal to 1? If you see, it will be equal to n, where n is the, what we can say, height of number of rows, and let's call f of 1 as number of operations required to make all of whole column equal to 1. It will be equal to n minus f of 1, no, occurrence of 1, sorry. So n is 5 and occurrence of 1 is 2. So answer comes out to 3, because obviously which are not 1 I have to make them equal to 1. Now similarly what f of 2, what will be the value of f of 2? F of 2 will be equal to n minus occurrences of 2 in that column, which is 5 minus 1, which is 4. So everything except 2 I have to cut them and make them equal to 2. Remove them and make them equal to 2. So I got this is a first observation, that for making all the elements in a column equal to x, what I have to do, The number of operations required are n minus occurrence of x. So I will just write it down. So f of x in ith column will be equal to n minus occurrences of x in ith column. Now, second observation. Let's say I have a grid up to m. I can make the columns. I can make all the elements of first column equal to 0 to any value from 0 to 9. Similarly, in so I have 10 number of 10 possible uh, options. Similar, but in while completing the second column, I have only nine what you can say 9 options, because if I fill one here or any other element, I cannot fill one again here one again. So that one possible option is removed. Similarly, for third column, again I have 9 options, because uh, one of the number from 0 to 9 will match the uh, previous number num previous number of previous column. So again, number of options to fill third column will be 9. So this will continue up to m. But what is important here is, while filling the third column, I only required the previous integer, or we can say previous integer which was filled. So looking at this combination, we can say that we can use a recursive code where I am filling any number from 0 to 9 in this column. Then I will go to right, and then I will fill again any numbers from 0 to 9 which does not match the first, what we can say, the first column. Then again I will move this, and I will try all possible combinations and find the final minimum answer, because I cannot see any greedy type logic uh, for minimizing the what for minimizing the cost, because if this changes, the second column is dependent on first, so the number of operations for this also changes. Again, this changes the number of operations for third column, and everything is dependent on each other, or in simple terms, the previous column. So uh, what I have to do is, let's call an recursive call or a DP state, such that I am currently at ith column, and the previous column was filled with j number. J means j can be anything from 0 to 9, and I can be anything from 0 to 1000. So this was the main understanding of this question. Now you can do this recursively, but tabulation is iterative DP is more easier in this question. And if you see, if you want to do memoization, the constraints for I is 1000 and constraint for j is 10, so it will come out to be around 10 is to the power 5, and additional 10 for iterating over 0 to n, so which is 10 is to the power 6. Now I will suggest you try this using this recursive DP or whatever you like. And if you still don't understand this, I will now explain the code. So at this position you can pause the video and try it by yourself, and if you still don't understand it now, then you can continue the video. So now we will see the code for it. So first I calculated n and m. Here they are given m and n, but it just confuses me because I have solved all the questions considering n as rows and m as columns. So then what I'm doing is I'm storing pre-computing for each column, and for each column what I'm doing is I'm storing 10 values. So that 10 values is from 0 to 9, and what I'm storing is for ith column and making that ith column equal to j. What is the what we can say, what is the required number of operations? So first of all I am iterating over column, then for each column I am counting the frequency of each integer from 0 to 9 in CNT, and in each column for j 0 to 9 I am storing n minus CNT of j, as we discussed the formula. F of x in ith column will be equal to n minus occurrence of x in ith column. So CNT f of j in ith column will be equal to n minus CNT of j. So in this vector 2D vector I pre-computed uh, all the cost operations for making ith column equal to j. Now then what I'm doing is so let's just I have printed this also. So for better understanding you can just print this and see all the values in DP are correct or not. Then I am declaring a dp2 vector. So let's first let's take the second case. So 1 1 1 and 0 0 0. Now how this column will look like in the dp vector? So it will dp of 0 first. Now what is dp of 0? It is uh, the number of operations required from 0 to 9 in first column. Now for making all the values in first column equal to 0, the number of operations required is 1. Again for making all the elements in first column equal to 1, the number of operations is 1, because I can just cut this 0 and make it 1. Now the number of operations required for in integer 2 to make all the elements in first column integer 2 is 2. Cut this 1, make it 2, cut this 0, make it 2. Now this will continue till 0 1 2 3 4 5 6 7 8 9. Similarly dp of 1 will look like same as this, because the column itself is same, and again dp of 2 will look like this. Now let's say I am at position dp of I and position j. I am filling ith column with j integer. So where I am going to let's call it recursion of I comma j for better understanding. So from I to j, what will be my transition? So first of all, I am filling ith column with j. I should add dp of I comma ij in my answer plus now the transition should look like recursion of I minus 1, that is moving to left column. We are starting from right, moving to left column. Now this second what we can say, second parameter j, it will we have to make 9 calls here, not only one. So what are those nine calls? Every integer from 0 to 9, but except which is equal to j itself. So it can be 0, then again dp of I comma j. So this should be minimum of all those calls. This is first call. Then second call is recursion of I minus 1 comma 1. This will repeat up to 9, but except j. If there is j equal to 5, I don't have to make a recursive call for that. So this is a basic transition, and so basically for each step we are making 9 calls, but due to memoization there are only 10 to the power 5 unique calls. So for that, what I'm doing is, now first column will be same as dp of 0 because there is only single column and it is independent of from its previous because there is no other column before it. And then I'm iterating from 1 to m, and for each j 0 to 10, first I have declared an sum as int max. Then what I am iterating over all values from 0 to 10, and if j equal to k, then here what I have to I cannot make the current column equal to its previous column. Then I have to ignore this, and after if it is not equal to k, what I'm doing is, first of all there will be dp of ij requirement of uh, the number of operations will be required to make ith column equal to j, and I will move to I will take the sum and the transition which look like this, recursion of I minus 1 and j, that recursion of I minus 1 and all the values from 0 to 9 such that it is not equal to j, so that is basically k. And so then I'm taking minimum of all those values and storing it into my dp. So first dp of 0 will get filled, then based on this 0 1 will get filled, and based on this one 2 will get filled. So this was pretty intuitive to understand, so I didn't write recursive code, I opted for iterative code. And finally I'm just taking minimum of all the possible combinations in last column, and that is the solution here. I think uh, this was also kind of easy if you have solved iterative type of questions or dp on grid type of questions. So let's move on to fourth question. Now fourth question is also standard, but I have never solved this type of question before, so it was, I knew the concept but I never solved any question in contest, so it was good practice for me, I would say. So in this question what we are given is, we are given an undirected weighted graph of n nodes from 0 to n minus 1, and it contains m edges where age of I is from ai to bi with weight wi. And what we have to do is we have to find all the shortest paths from 0 to n minus 1, and if uh, and we have to also initiate an boolean array of answer, and return that answer vector, but we have to make changes in that answer. That is, answer of I should be true if ages of I is a part of at least one of the shortest paths, and otherwise answer of I will remain false, and finally we have to return that answer. So let's take the first case. I will just draw this graph. Why? Now in this case, if you find all the shortest paths, they will be, I think there are two shortest paths of total cost 5. So one shortest path is from 0 go to 2, from 2 go to 3, and from 3 go to 5. Now, and second way is from 0 go to 1, and then 1 to 5. And I think there is another way. So what is that? 0 to 3. Okay. 0, 2, 3, 1, 5. Now if you see, there are three shortest paths, and this is it's these three are the shortest path, and all of them, all the weights total cost is 5 in each path. Now what we have to do is mark all these edges, adjacent edges, as 1, as true is this, mark an index of that edge with respect to edges of I vector. So for example, in this case, first edge was 0 to 1. Now 0 to 1 is present in one of the shortest path. That's why the 0th index in answer vector is true. Now 0 to 2 is again a part of one of the shortest path, so this is true again. Now 1 to 4 is not a part of any shortest path, 1 to 4 edge, so the corresponding value in answer array is false. Similarly, 4 to 5 is not a part of edge. 4 to 5 is not part of any shortest path, so the corresponding value is false again. So basically we have to just return this answer boolean array. Now to do this, obviously there is shortest path in problem, so we have to use Dijkstra, but there are slight modifications to it. What are those? So let's say I'm going from 3 to 1, and this is x, this is y, and this is w, and current length was, so what x is? X is the current weight to reach 3, distance of 3 from source node. W is weight of this age, and y is d of 1, let's say. This cannot be possible, but let's consider this as 5. So 5. Now, what are possible conditions of this? Now d of 3 plus w is either less than d of 5. Now this is the basic condition in Dijkstra. Then what we do, let's first write all the conditions. Second condition is like d of 3 plus w greater than d of 5. And there is another condition where d of 3 plus w equal to d of 5. While performing the extra, we only need the path sum or shortest paths weighted sum. But while finding all shortest path, we also need to additionally take care of this condition. Now you will see why. Because now let's say this condition. If this is the condition, that means this distance was first ever distance till 3, which was able to reach 5 in shortest path possible. So in this case, parent of 5, because for shortest path there we can find shortest path by maintaining a parent array, maintaining parents of any node. So parent of 5 will be unique, and that will be 3 only, because that itself is the first ever node to reach 5 in such short path. Now in second condition, 3 cannot be a parent of 5, because we have already a parent of 5 which is going till 5 with less cost or less weighted sum. Now when d of 3 is equal to 5, for example, so for this condition I add an additional node from 4, and it is somehow reaching this my target node in y distance, that is d of 5. Now this can also be a shortest path, this 3 to 5. So we also need to consider 3 as parent of 5, and consider all the shortest path, all the paths which 5 has come from. So in this case, p of 5 are 3 and 4 both, because this 4 is already a parent, but additionally 3 has become one of the parents. So I have to maintain a vector of parents for each node. And let's say this is n minus 1. Now n minus 1 had x1, x2, x3 parents. Now x1 had another y1, y2 parents, and x2 had y3, y4 two parents, and x3 had only one parent, x5, and all the parents have one parent, that is 0, which is our source node. So this our parent vector of parent 2D vector itself becomes a graph, but this is directed graph from child to parent, you can say, opposite type of directed graph. Now for this we can just use BFS or DFS as you like, but mark each node whenever they are visited, because I don't think they will be visited twice in any case. uh, so you don't need the marking vector to mark the vector, but uh, for storing that age as one, we have to make a map of pair in comma pair of integers. So there was there are some slight modification in the extra, and then this BFS on parent graph, direct parent graph, director graph of parents. So this is, if you see code, you will better understand it, I guess. So what I'm doing is, first I'm creating an adjacency list with weights. This is the usual way of creating adjacent list, and I'm also mapping pair of ages to index. So to map ages uniquely, what I do is I generally make first element as minimum of UNV and second element as maximum of UNV, and I'm mapping that pair with I is current index. Then this is the standard code of Dijkstra. This is distance vector. This is parents 2D vector. Then I have declared a set. You can use sprite queue, but I find set easier. Now this is standard Dijkstra code. The modifications are over here. So first of all, if d of v plus length is less than equal to d of 2, that is this condition. So I have to remove all the parents which I have stored previously. So p of 2 dot clear, and there will be only one parent, unique parent for start. For example, p of 5 will be 3 for this condition, because 3 is first ever parent of 5, which is reaching 5 in such shortest path. And if I find this condition as d of v plus length equal to d of 2, I have to push additional v as one of the parents of 2. So in this case, where there are multiple parents, using this Dijkstra, I got all the parents of in shortest path. Now I am declaring an boolean answer as ages.size. So this is our final answer which we have to return. And I have declared a CNT as n minus 1, and I have declared a q2, and this is just BFS code where I'm uh, this BFS code is on this way, directed graph which was created by this parents. So then what I'm doing is, for each child, I am iterating in each of these parents. From n minus 1, I will go to x1, x2, x3, and if I have already mapped it as true, then I will continue. That is, I will not add it additionally in my uh, queue, and if it is not marked, I will mark it as 1 and push that parent in my queue, and then I will return answer. So this was also, I would say, you have to break the question into two parts. First, find all the parents, this parent type of 2D vector which is graph itself, and how these two conditions are important, how they work. So this was first part of question, and this is second part where you traverse over the parents graph. And I think that's it from my side. Uh, I solved it pretty fast, but this first wrong submission first question was not necessary. But yeah, thanks. That's it from my side, and thanks for watching.